Okay, class, another topic in power plant engineering, fuels and combustion. Okay, so let us first take up some definitions. Okay, so in order for us to compute problems in fuel and combustions, or fuel and combustion, we need first to know what are those definitions and terms used in fuel and combustion. Okay, so let us first define what is fuel. Okay, so fuel is composed of chemical elements which is in rapid chemical union with oxygen produced combustion. So union of fuel and oxygen produce combustion. So therefore, without the presence of oxygen, it is impossible for a fuel to ignite. Okay? So what is also combustion? So combustion is rapid chemical union with oxygen of an element whose exothermic heat of reaction is sufficiently great and whose rate of reaction is sufficiently fast that useful quantities of heat are liberated at elevated temperature. So that is combustion, rapid union of fuel and oxygen. Okay? So, so let us take now the classification of fuels. Okay? Of course, we have the solid, we have liquid, and of course, gaseous fuel. So, solid fuels, so include of course coal, coke, peat, briquettes, wood, charcoal, and waste products. Okay? So, bagas. So, coming from the sugarcane milling. Okay? So, we have also the liquid fuels. So, including petroleum products. So, of course, are those hydrocarbon fuels. Okay? So, mostly. So, synthetic liquid fuels manufactured from natural gas and coal, shale oil, coal byproducts, including tars and light oil, and alcohols. Okay? So, we have also another, the gaseous fuel. So, this including natural gas manufactured in industrial gas, product gas, and the propane and butane or LPG or the liquefied petroleum gas. Okay? So, we have also classification of coal. Okay? So, classification by rank. Okay? So, what is this classification by rank of a coal? So, this is the degree of metamorphism or progressive alteration and the natural series from lignite to anthracite. Okay? By rank. So, of course, the lower level of the coal is lignite. Okay? Other is subbituminous, semi-bituminous, bituminous, semi-anthracite, anthracite, and super anthracite. Okay? So, probably the most universally applicable method of classification in which coals are arranged according to fixed carbon content and calorific value. So, calculated on the mineral matter basis. Okay. Another is the classification by grade. So, quality determined by size designation. You have calorific value as softening temperature and sulfur. So, the size designation is given first in accordance with the standard screen analysis method followed by calorific value. And symbol representing as softening temperature and sulfur. Okay. Classification by type or variety. So, determined by the nature, the original plant material, and subsequent thereof. Okay. So, another we have the burners for pulverized coal. So this is now in a steam generator plant. Okay? So in the furnace. So we have the vertical firing. So with all the secondary air admitted around the burner nozzle so that it mixes quickly with coal primary air mixture from the burner nozzle. Okay? Other is impact firing. Okay? A form of vertical firing consists of burners located in an arc low in the furnace or in the side walls and directed toward the furnace door with high velocities of both primary and secondary air. So this type of firing is used exclusively in wet bottom or slugging type. Okay. Another is horizontal firing. So employs a turbulent burner which consists of a circular nozzle within a housing provided with adjustable valves, the unit being located in the front or rear wall. Okay. So another we have the corner or tangential firing. So this is characterized by a burner located in its corner of the furnace and directed tangent to a horizontal. So imaginary cell in the middle of the furnace, thereby making the furnace the burner in its effect, since turbulence and intensive mixing occur where the streams okay. We have also Coke. So what is Coke? Solid infusible solid after bituminous coal are heated and the absence of air above temperature of its active thermal decomposition of the coal occurs. Okay? So we have pitch coke or petroleum coke. So are obtained by similar heating of coal tar, pitch, and petroleum residues. We have high temperature coke. So it's made from coal at temperature ranging from 815 to 1093 degrees Celsius. So another we have low temperature coal or coke rather. So it's formed at temperature below 704 degrees Celsius. Okay? Another is charcoal. So charcoal is produced by partial combustion of wood at about 400 degrees and with limited air. Okay? Liquid fuels or fuel oil, okay, is defined as any liquid or liquefiable petroleum products born for the generation of heat in a furnace or firebox. Okay? Okay. So, four classes of fuel oils. Okay? Common uses. Okay? Residual oil. So, which are top crude petroleums or viscous residue obtained in refinery operation. Okay? Other is distillate fuel oils, which are distillates derived directly or indirectly from crude petroleum. So another is crude petroleums and weathered crude petroleums of relatively low commercial value. Another is blended fuels. Okay. So another, we have the commercial fuel oil specification. So we have several here. So grade 1, grade 2, 4, 5, and 6. Okay. Grade 1 is a distillate oil intended for vaporizing fat type burners and other burners requiring this grade of fuel. Grade 2, a distillate oil for general purpose domestic heating. Okay. Grade 4, an oil for burner installation not equipped preheating facilities. Grade 5, a residual type oil for burner installation equipped with preheating facilities. And grade 6, an oil for burners equipped with preheating or emitting high viscosity fuel. Okay. Another we have now, the gasoline. Okay. So gasoline commonly used for an O2 engine. Okay. So gasoline is defined as a refined petroleum naphtha which why its composition is suitable for use as carburant and internal combustion engines. Okay? Motor gasoline. So, a mixture of hydrocarbon distilling and the range of 37.7 degrees to 204.4 degrees Celsius by the standard method of test. Okay? Another is kerosene. Okay? So, kerosene is defined as petroleum distillate having plus point not below 22.8 degrees Celsius. So, as determined by the Havel tester and suitable as an illuminant when burned in a wick lamp. Okay? Another is coal tar. So, coal tar is a product of the destructive distillation of bituminous coal carried out at high temperature. Okay? Another is LPG, liquefied petroleum gas. So, are a mixture of hydrocarbons liquefied under pressure for efficient transportation. So, storage and use. Okay? So, another we have the diesel fuel. So, of course, diesel fuel is an oil or a fuel used for a diesel engine. Okay? So, we have here ABC. So, distillate fuels. So, are probably by distillation of crudes. Residual fuels are those left after the distillation process. Blended fuels are mixture of straight distillate fuels with crack fuel stock. So, what is a crack fuel stock? Okay. A residual of fuels which have been created thermally or catalytically to obtain yield of lighter grade fuels or gasoline. Other is the lightest grade distillates. So, classed as kerosene or number 1 fuel oil. So, we have an initial boiling point of 176.6 degrees Celsius and end point of 260 degrees Celsius. And then we have the heaviest grades of distillates. So, classed as number 3 or 4 fuel. Okay? So, initial boiling point of this is 232 degrees to 216 and of point of 343 to 371 degrees. Okay? So, residual fuel number 4 or 5. So, that is suitable only for the slower speed diesel. Okay? Another, we have the gaseous fuels. Okay? So, commonly used in industry whether distributed by public utilities or produced in isolated plants. So, are composed of one or more simple gases in varying proportions. Another is diesel lubricating oils. So, crude oils are frequently described as paraffinic or naphthenic or mixed based according to physical characteristics of the crude. Okay? Two broad types of oil. So, we have the straight oils and additive oil. So, straight, of course, are produced entirely from crude chosen through elimination of undesired constituent by suitable refining processes. And for additive oils, are produced by adding straight mineral oils, certain oil-soluble compound that enhance the lubricating oil properties for use in a diesel engine. Okay? What is this additives? So, are used principally to inhibit or slow down oxidation. Okay? Slow down oxidation. So, to increase film strength, to keep solids in fine divided state, and to hold them in suspension. So, to improve the viscosity index, lower the pour points, to decrease friction and wear under extreme pressure conditions. So, to reduce foaming and as rust or corrosion inhibitions or inhibitors. Okay? So, we have here the site 3 types of lubricating oil. So, this is Society of Automotive Engineers. Okay? So, we have here regular type, premium type, and heavy duty type. Okay? Sign numbers, so are means of coordinating and standardizing the products of oil companies and the recommendation by oil companies. So, the system of SI, motor classification, is a system based entirely on viscosity and is totally unrelated the other quantities or qualities of lubricating oil. Okay, so another is we have the specific gravity. Okay, so a dimensionless parameter is the ratio of the mass of the unit volume of the fuel to the mass of the same volume of standard substance. Okay, so by this time, the standard substance, of course, is the water. So this is used for determining the specific gravity of the liquid fuel. Okay, so we have now specific gravity equals the density of the liquid fuel divided by the density of water. Okay, so that is now how you are going to determine that. Okay, so for gaseous fuel, so that is density of gaseous fuel divided by the density of air. So take note that the standard liquid used is water, and for the standard gas, we use the air. Okay? So another, we have here the specific gravity of the fuel at temperature T. So actually, this was already discussed in the first presentation in power plant engineering. Okay? So we have here the specific gravity at temperature T is equals to specific gravity at 15.6 or 60 degrees Fahrenheit multiplied by 1 minus 0.007 multiplied by the temperature, the actual temperature, minus 15.6. Okay? So this is in SI. So if we now use the English units, we have here specific gravity at temperature T and degrees Fahrenheit is equals to specific gravity at 60 degrees Fahrenheit multiplied by 1 minus 0.0004 multiplied by T minus 60. So that is now the formula in determining the specific gravity of fuel at different temperatures. So by this time, we can now take note of this formula because maybe in the other presentation, we have here now or we will now use this formula for actual calculation. Okay? So another, so we have the relationship of the American Petroleum Institute. Okay? So we have the EPI. Okay? So, and specific gravity. So, degree EPI. So, this was already presented in a previous discussion. So, degree EPI is equals to 141.5 over specific gravity at 15.6 minus 131.5. And for degree bombing, so we have here 140 over specific gravity at 15.6 minus 130. Take note, this is used in commonly for brine. Okay? So, another definitions or another simple or basic formula which is very important in combustion calculation. Okay? So by this time, so this is now the end of my presentation. Thank you very much.